All right, so we are in AP Calculus. AB, we are on self-check 9.1. Today's date is Monday, February 10th, 2020. We have this fancy table, and we're talking about voting on a zoo something name, right?
The name of the baby elephant.
Baby elephant name, that's right. All right, so,
You should get to name that.
yeah, I don't know.
Last two guys got to name it, so.
Elephanty McElephant face or something like that.
It was Gilbert.
So part A is pretty straightforward. So at time equals 6, what is the approximate rate? So if you ever see the words approximate rate, you need to be seeing, okay, where is 6? And hopefully you know that 6 is in between 2 and 5. I know that is
In between 5 and 7.
in between 5 and 7. 6 is in between 5 and 7, which means I am going to do capital E of 7 minus capital E of 5, all divided by 7 minus 5. And we do have a calculator to assist us on this one, even though we don't really need it yet. E of 7 is 21, E of 5 is 13, and then all that's divided by 2 because 7 minus 5 is 2, and then 21 minus 13, that's going to be 8 over 2, which is 4, and that's going to be entries per hour.
Hundreds of it.
For hundreds of entries per hour, yeah. Hundreds of entries per hour.
That's how I wrote it too.
Can A be out of 9 points?
No. So this, by the way, came from 2010. The version A, so it's one of the easier types, not version B. Question number 2. Again, question 1 and 2 are always calculated. That's how you can tell that this one is calculator enabled. How to score yourself? You get 1 point if you got the right answer, just 4. So if you got 4 plus 1, and it is out of 1 point off to the side. So part B, we are using a trapezoidal sum with 4 sub-intervals, which makes sense because I have 1, 2, 3, 4. So I'm using all of the data from the table to approximate that value of 1/8 of that integral. So I'm going to write this out again. I'm going to say 1/8 of the integral from 0 to 8 of capital E of t dt is going to equal. All right, we have to find lots and lots of averages. Again, whenever you have trapezoidal sum, that means you're finding averages. So I'm going to write the average value in between. So the average of 0 and 4. Again, if you don't know how to find the average, add them together, divide by 2. 0 plus 4 is 4, divide by 2 is 2. The average of 4 and 13 is 17 halves. Average of 21 and 13, that's going to be 34 over 2, that's 17. And 21 and 23 is 22.
It's not 7 halves.
17 halves.
Isn't it 9 halves for between 4 and 13?
It's not 9 halves, so if I add 4 and 13, I get 17, and then divide that by 2 is 17 halves.
Okay.
I think, but I'm wrong lots. I learn lots. That means I come back down here, I add all those together, so gosh. Okay, so it's going to be 2 minus 0 times the height of 2. You times the height of whatever the average is, right? So I'm going to write down here, this is going to be, you have to show your work, I think. It doesn't say that. Oh, it doesn't. Okay, some of them say you have to show your work, so I guess you don't get a point on showing your work for this one, maybe for the scoring guide. But I'm still going to do it. So 2 minus 0 times the average of 2. And then I'm going to add 5 minus 2. 5 minus 2 times the average, which is 17 halves. 17 over 2. Plus the next one is 7 minus 5. And the average between 7 and 5 is 17. What's going on there?
That's wrong.
I'm wrong.
No, I'm sorry. I was
Oh.
right here.
And then plus 8 minus 7. 8. 8 minus 7, which is just 1, I guess. And then times 22. 22. Let's go ahead and simplify this bad boy. 2 minus 0 times 2, that's 4. That's 3 times 17 halves. That's 2 times 17, which goes back up to 34. We start with 34 to begin with, and then that's 22. I need to add all of these numbers together, and unfortunately we have that fraction. Let's add all the non-fractions together first. So I have 4 and 34, which makes 38. 38 and 22 is 60.
You also have a calculator. But you
Oh my gosh, we do have a calculator. Okay, that would have saved us a lot of work. I totally forgot about that. But if I do all of that math correctly, I think, do I have it written down here? I do not.
17 halves is 8.5
Ah, that helps a lot. This is 25.5. And then I can add that to what I say, 60, and I get 85.5. So 85.5, 0.5 is when I add all that together, and I forgot to multiply by 1/8. So all this stuff times 1/8, because I have to originally do that stuff on the outside as well. So I'm going to move.
Well, even if you just multiply 85 times 85.5 times 1/8.
Yeah, I mean, that you'll get the answer then. So this is all going to be times 1/8 out front. So I have 1/8 of this, and then that's where I actually do need a calculator. So let's pull this back up. Now let's get out of that. I have 85.5 divided by 8, and I get 10.688. So this is equal to 10.688, and that is what they got for the answer key, I hope. Yes, 10.688. Okay, so 1 point if you somehow show that you're using the trapezoidal sum formula correctly. So some sort of showing your work or showing that you're using trapezoidal sum. So that's me doing it right here, plus 1. I'm attempting to use trapezoidal sum. Notice it doesn't say trapezoidal sum correct, I think. I think if you're just trying it, you'll get the point, but I'm not 100% about that. 100% sure. Approximation. Oh, we didn't even finish answering this thing. So plus 1 if you got 10.688. And now we need to answer the second part of the question, which is using the correct units, explain what this thing even means. So whenever I have a fraction of an integral, it's always the average value of whatever is on the inside. If that inside is a number, an amount, a rate, it doesn't matter. This is saying what is the average of E of t. So and what is E of t? What is the average number of entries? Is the way that I would explain this. Who dat? All right, so write it out here. We say this is the average number of entries in hundreds of entries from, what is our time interval from 0 to 8? From 0 to 8, and our units I think are hours for the time. Yes, it does say hours on our table, hours. Oh, and I had to go to the next line. All right, and let's see exactly what the solution guide has in store for us. Average number of entries between noon and 8 p.m. It doesn't matter if you interpret it that much, but between time is equal to whatever and whatever is fine. I should say from t is equal to 8, I guess, to be more accurate about what I'm saying. Come on, let me, from t is equal to 0 to 8 hours. All right, so that's plus 1 point if you got that. And that is a total out of 3.
Well, I got 0.
Darn.
I kind of forgot about the trapezoidal.
Okay, so, but now you know it better now?
I just did homework last night, so.
So wait,
Nice and fresh.
when you find the average from between the other things, it's like
Add them together.
and
Divide by 2. Perfect, yep.
That's all I need.
Other questions before we move on to part C? Okay, now they're going to start processing their entries. We've kind of cut off the table. We say, okay, we're now right here. We have 2,300 entries, so 2,300 entries. And now we're going to start processing those entries at this rate. And now this is where we need the calculator, right? So now we're starting at time is equal to 8, which is where we left off in our table. So we start off at that time, and we're going to hopefully end by midnight, by 12. And yet it even tells you midnight, time equals 12. How many entries have not been processed? Oh, so they don't even finish then. So they finish at 12 and they're like, shoot, we still have how many entries left? Well, how do we figure that out? Well, we know that we started now with 2,300 entries. So since all of our units are in hundreds of entries, I'm not going to say 2,300. I'm just going to leave the number 23. And I'll leave the units as hundreds of entries. So this is a start plus change equals n type of problem. Start plus change. That's going to equal to the end. What's up? That's, well, Mr. Godoy is to charge the battery in the light. So the start here is 23. And the change is going to be the integral. And if you can't find a good one, I have some back in this cabinet. The integral, and I'm starting at 8 now. So 8 to, and I can actually, I know my end, 12. I don't have to do time t for any time. And then it's going to be of that capital P of t dt. So I do this on my calculator. So first I enter my equation correctly, hopefully I have that correct, and then once I do that I do 23 plus math 9, the integral of, var is right, enter my y1 function with respect to x from 8 to 12, and it will tell me 39. That's, oh, I need to subtract that amount because this represents a negative rate. So come back here. I have to subtract this amount because otherwise I have more entries. That doesn't make sense. They cut off the pole. So subtract here. If I hit second enter, I can come back to the previous line and hit a minus instead of a plus, so I don't have to retype all that in again. Oh, I only have 700 entries left after midnight, so this is equal to 7.
I got negative 321.
I got
Ooh.
I got close.
You got really close. I wonder what your mistake was.
Yeah.
Did you do like 24 instead of 23?
No, I don't know. Because
Huh.
I put that equation in and then I plugged in 12. But then I don't know.
And then I just
Yeah, this is a good time. Like, spend the time, analyze your error. What happened? Try to figure out what you
I
did.
entered it wrong in here because I have it set up correctly. I just
Check your y1 function. Does it look like
I
this?
didn't put it in Y1. I just entered it in the
Oh.
function.
Can you still see it? Is it still on your calculator?
No.
Or if not, can you
I
hit
cleared
second
it.
entry? Second enter to see if your equation was correct.
It was x
No.
Cubed.
to
To the power of caret.
to the power of 3. Thank you. Minus 30x squared plus 289x.
Oh, 98x. Not 89. Darn. That was just a tiny mistake.
Oh, for real?
Yep.
That's all that happened?
That's all that happened.
That's
How to score
seriously all
yourself.
that happened.
For part C, you get 1 point for the integral, 1 point for the answer. So that's the wrong score guide. So if I have this integral right here, the entire thing, give yourself 1 point. You don't have to subtract it; they don't care. But if you actually got the right answer, then +1. That was out of 2 points. Everyone is scoring themselves for part C. We're
Wait, so
good.
if we get the integral, we get a point?
If you wrote the integral between 8 and 12 of p of t dt, you give yourself 1 point. Yes. All right. So for part D. Looking at part C, when were entries being processed most quickly? So when I see the words most quickly, I'm thinking of a max. Usually when I see max, I'm thinking of table of start plus change equals n, but that's only if it's talking about a maximum of an amount. This is talking about a maximum of a rate, so being processed. So what is the max rate? And the only way to do this one is really with a graph of your calculator. So my graph is still in there. If I have my correct window from 8 to 12 and I zoom 0, I get this graph. And I don't need to shift it up or down. I don't need to add 23. 23 is not a rate or anything. This is purely just a graph of the rate. And it's asking, what is the highest height of that graph? And it's pretty clear that it's right there at the very end at time is equal to 12 at midnight. You can think about this in the terms of the context. It's like, they're doing well, kind of got tired. Oh no, shoot, we're like running out of time. We don't get paid after midnight. We need to do this as fast as we can. And they still don't finish in time still, right? So 700 entries are still left over. So for this one, we basically just need to say, okay, the answer's there, but why? So it's still a table of start. It's not start plus change. It's a table very similar. So let's go ahead and set up our table here. What is our table really happening? Or what is cannot speak today. What is really happening in this table? I guess it doesn't need to be that big because it's not start plus change. It's really your time t's. All of the time t's are always going to be the same. I have to check the beginning at 8. I have to check the end at 12. I need to check all of the relative extremas. Again, relative extremas on this graph. Where do I have a maximum? Well, I have a maximum there. I have a minimum there. So I need to check that value theoretically. I need to check that value theoretically. But really the answer is going to be right there. So how do I find that t value? Well, it's going to be a second calculate to trace the maximum for. And I've noticed that if I hit 8, it doesn't work, so I'm going to do 8.1, slightly bigger for my left boundary. My right boundary, let's do 11, and then, I don't know, 10. It's going to tell us that this is 9.183. 9.183, and then I have to check the other one as well. So I'm going to do, well, I don't have to, but I guess I'm just going to put it out there for the sake of doing it. What is the minimum? So I'm going to hit 3 between, I'm going to guess that this is about at 11, so I'm going to say between 10 and 11.5. I'm going to guess 11. It's going to tell me it's at 10.8 10.816. So 10.816. So those are the t values. You do need to somehow say, hey, I'm checking those values. And then what am I checking? I'm checking the height. Which one is the highest? So you're really just checking, you're plugging in P of t. What is the P of t value? What is your value that you're getting out of this? So when I plug in 8, you'll get 0. If I go trace and I hit 8, 0. The y value is 0. So I can come over here and say, yes, that's 0. When I type in 9.183, I guess we could have done that before and just taken a look at it. 9.183, I get 5.089. 5.089. If I come over here to 10.816, it's obviously lower. 2.911. 2.911, and then 12 will give me my maximum, which is, exactly equal to 8. So, which one of these is the biggest? That one. So how do we say that? We say processed most quickly at time is equal to 12 at 800, or 8, I guess, hundreds of entries per hour. Cool. So there's our answer. How do we score ourselves? So on our self-check, our guide, we have, okay, you do have to somehow set p prime is equal to 0. If there's some evidence of that, you can give yourself 1 point. The only evidence that we have is actually getting those values. So we get 1 point by saying, hey, we set it equal to 0, and then you get another point for actually finding those candidates. Well, we found those candidates, so we get 1 point again for just listing those points. One of them was saying, hey, we were setting it equal to 0. One of them is, hey, those are the answers when they're set equal to 0. And then finally, answer with justification. So our answer is, yeah, time is equal to 12 at 800s per hour. Boom, plus 1 point. And that's exactly what they say here too. Time is equal to 12. Our justification comes from our table. So that one was out of 3 points. Oop, lag. Come on, computer, go. There it goes. 3, 4, 5, 6, 7, 8, 9. Okay, yeah, so this one is out of 9 points. Go ahead and score yourselves. After you're done with that, we're going to give ourselves 10 minutes for self-check 9.2. All right, so on to self-check 9.2. I had to do this after everyone left. All right, so we have oven things happening here, and this is the temperature of the oven over a 16-minute period. Instantaneous rate of change at time is equal to 10. So 10, I'm going to do this correctly. It is in between 8 and 12, which means to approximate this, I'm going to do capital H of, well, I'll maybe write down my answer a little bit more formally this time. H of 10, H prime of 10 is approximately equal to capital H of 12 minus capital H of 8, right there, all divided by 12 minus 8. 12 minus 8. So H of 12 is 80. H of 8 is 73. I can write slightly neater. And this is all going to be divided by 4. And that's 7 on the top, 4 on the bottom. Okay, I could just leave this as 7/4. Indicate units of measure. Okay, we're degrees Celsius divided by minutes, so degrees Celsius per minute. Degrees Celsius per minute. How to score yourself. Let me get rid of this old scoring guide. Don't save. Yep. So this one came from AP, just version A. Don't know what year this was. Yeah, I guess I could look it up later, but it's question number 3. Yes, so 7/4, we got a difference with quotient, so something that looks like that, where you have a difference in a fraction, and answer with units. So came back over here. You actually get a point for having just that, or just that, one of the other. So I'm going to give myself +1 in between there, and then +1 for getting the answer. Did it have anything about units in the self-check? Yeah, answer with units. So if you don't get the units in, you don't get the answer. That one was out of 2 points. I'm going to do it off to the right here. Out of 2. Right, an integral expression for the average temperature. Okay, so average between 0 and 16. So I'm thinking integral between 0 and 16 of your capital H of t. So capital H of t dt. And then I'm going to divide this all by 16 minus 0. Or alternatively, if you want to save some space, you can say 1 over 16 minus 0 out on the side. It doesn't really matter one way or the other. So there it is. There's the integral expression. That's the point. And then it says now estimate the average temperature. So hold on, let me move this over. I just want to make this look nicer. Like that. Okay. And then estimate that using a left Riemann sum with 4 intervals of equal length. Okay, so, and then show computation. So we do have to show our work on this one. That's what I was thinking of the last time. So how do we do this? There's a kind of a quicker way of doing this now. So this is now going to be, I'm trying to write the approximately squiggly equal to sign. Technically, you're supposed to do it the long way. I'll show you the long way really quickly. So 4 minus 0, and then it's left, so I times the height of 65. I draw my Tetris piece like that. Yeah, so 4 minus 0, 4 minus 0 times the quantity of 65 plus, and then it's going to be 8 minus 4 times 68. 8 minus 4 times 68. So this is the long way of doing it. There's a shortcut in this one. This is totally correct. If you did this, you're doing it right. It's just there's a quicker way, I guess. So the quicker way of doing this is noting, hey, each of these intervals is 4. So what essentially I'm going to do is I'm going to factor out of 4 and say, hey, this is 4 times the quantity of all the heights. You just add them up. 65 plus 68, 73, 68 plus 73 plus 80. And I know that I'm not going to use that rightmost value because of the left Riemann sum. The Tetris piece, I'll leave that one out. I factor out the 4 and then just add these all together. So if I add these all together, that's 286, I think. Hopefully I'm doing that right. And then don't forget to divide by 16. So divide this all by 16. Notice that the 4 and the 16 are going to cross cancel here, so that's going to be a 4 on the bottom. This is now equal to 286 over 4. And if I do this, thinking, how do I do this without a calculator? Well, 280 is 70, so 71.5. It's equal to 71.5, and don't have to do units, but I'm going to do them anyway. This should be the average temperature. So our units should be whatever that temperature is. It says, if it said average rate, you'll do the units of rate. This is a temperature, so it's just degrees Celsius. I'll go ahead and box it. How do we score ourselves? Part B. Yep, 71.5. Cool, we got it. So did you write that integral? Yes, so +1 if we wrote the integral. Did we somehow show a left Riemann sum work? Like you at least attempted it. You might have not done the math correct, but did you attempt it? We did, right there. And then finally, did you get the answer? We did, out of 3 points. All right, just checking. All right, so is our approximation an under or over estimate? And give a reason. So this one I can just type out. Actually, I'm going to maybe graph this one first. So, of course, you could just memorize, hey, left Riemann sum. Man, I still don't have these memorized. I'm really bad. I should have them memorized. I'm going to have to do a sketch. I'm sorry. So if I have a sketch, I have an increasing function. So it doesn't matter what's happening. Just something that's increasing. I use the leftmost point, leftmost point, leftmost point. And then I have some function that's happening here. It doesn't matter if it's curvy or not. And it should be going through those points. Is this an over or an under approximation? You can clearly see, hey, we forgot these little amounts of space, so this should be an under approximation. Oops. So I'll write here, this is under. Under the curve. And I use the word curve as like the line or curvy thing, whatever we're talking about. So I come down here, and I can write down my final answer. We can say, this is an underestimate, and the only reasoning that you need to write down is because. This is an underestimate because it is a left Riemann sum that is just increasing, yeah. That is increasing. There we go. Let's move this down here. Come on, computer, don't die on me. That's all the rationale that you have. Okay, so what did they say for their answer key? Over here, first of all, did we get it correct? It is an underestimate. Whoo! All right. And you have to say something about increasing, blah, blah, blah. I guess it is kind of useful to say, hey, it's not going to, dividing by 16 is not going to change if it's an under or over estimate. But yeah, increasing. That's the main thing that I'm taking away from their scoring guide. And you only get 1 point if you get the answer with reasoning, so +1 for our answer with reasoning, and that's going to be out of 1 point. Okay, part D is hard. Is is the data in the table, are the data in the table, I guess, this stuff up here, is that consistent with or do they contradict the claim that the temperature of the oven is increasing at an increasing rate? So the easiest way to answer this is by rewriting the table out here. You're looking at the second differences. So increasing, that's the first difference. All right. First difference. At an increasing rate means a second difference. What do I mean by that? Well, let's go ahead and draw our table. And before I talk about this problem too much, I haven't taught this. Like, if you, maybe I taught it a long time ago in maybe Algebra 2 or maybe briefly again in AP Calculus, but I haven't taught this, so you can still pass the AP test with a 5 without knowing how to do this one, but it is helpful to know how to talk about increasing at an increasing rate from a table. There will be one of these on the pretest and the test. I guarantee there's one on the test. So how to do this one? I'm going to redraw this table, so I'm gonna kind of ignore the t values. It doesn't really matter since they're uniform. If they were not uniform, it becomes such a headache where you have to calculate the average slope for every single one of these. But because they're nice and uniform, I'm ignoring them because they're all going to be the same rate. So I'm just going to say, let's list the table. So 65, 68. 65, 68, 73, 80, 73, 80, and then finally 90. 90. And I can shift these down a little bit so I can have some room up at the top. Oh my gosh, computer, you got this. Sure, right there. All right, so I'm now going to say, what are my first differences? First difference. So what's 68 minus 65? I went up 3. So I'm saying to get from here to here, what operation did I do? I went up 3. So I'm going to maybe go like that, plus 3. How to get from 68 to 73? Well, I had to add 5. And if you don't like writing plus 5, you don't have to. You can just say 3, 5. And if it's negative, then write a negative. To get from 73 to 80, I did plus 7. And to get from 80 to 90, I added 10. Okay, that was the first differences. The second differences, and you can probably guess, is the differences of the differences. So what's the difference between 3 and 5? To get from 3 to 5, I had to add 2. To get from 5 to 7, I had to add 2. To get from 7 to 10, I had to add 3. It doesn't matter what numbers they are. It just matters, are they positive or are they negative? Is it increasing or is it decreasing? In this case, they are all positive, so the first differences are all positive, therefore it is increasing. The second differences are also all positive, therefore it is increasing at an increasing rate. You can have increasing at a decreasing rate if all of these were negative. That's how you show it with a table. So this is consistent. We'll say, I'll type our answer. I don't know where I have room. Maybe I can move this all over. Come on, computer. Grab all this. I need some room to write. Oh my gosh. This computer is running like very, very, very slow. There we go. Grab all this stuff. Move it off to the side so I have some room to write. And I can now say, yes, this is consistent. Yes, this is consistent. With increasing at an increasing rate. Why? Because the first differences are all positive, and the second differences are also all positive. Positive. Done. I think the answer key that they give is like very confusing and hard to understand, but this is actually part of the new standards. So I'm teaching it in my other classes now. I think Algebra 2 just had a test on it a few months ago. Anyway, how do you score yourself? And dear gosh, whew, yeah, so that is difficult. Okay, so they're actually using the secant lines. They're not using my trick of knowing that since they're all 4, they're basically all the same. So what I did, I said, hey, look at that. 3, 5, 7, 10. That's what I did in my table over here. 3, 5, 7, 10. I didn't have to divide by 4. Normally, you have to always divide by the distance between here and here in terms of the times, the t values, whatever these are. Yeah, the t values. So normally you have to do that, but if they're all the same, you can skip that step. It's fine. They're all going to be the same either way. And then you can say the slopes are increasing at an increasing rate. Yeah, it's kind of hard to understand what they're saying here, but it makes a lot more sense with my explanation, in my opinion. So consider the slopes of the secant line. So if you somehow looked at the first differences, you're giving yourself 1 point. That's what they mean by the slopes of those differences. Oh no, slopes of the secant line. So they're actually coming back here. They're talking about this. They're They're talking about the second differences here. So if you somehow talked about the second differences, you can give yourself a point. Then explanation and conclusion is consistent with explanation. Now, that's an interesting way of scoring it. So yes, there's our explanation. We said yes, it is consistent. And why does it match up? Well, because the first differences are positive and the second differences are all negative. So once I start talking about this stuff, I think that's where the second point comes in. So that's going to be out of 3 points. And can you get points for just guessing? Conclusion is consistent with explanation? I don't think so. My guess would be no. If you just totally guess and be like, yes, no, you have to have the explanation, because it says here, you have to be able to explain. You can't just guess and say, notice how it doesn't say answer. If it said 1 point for answer, then I would be, oh yeah, if you guess it, you get a point, but no. Okay, so how many points do we have? We have 3, 4, 5, 6, 7, and 8, 9. Cool. So this is out of 9 points. Score yourself, and that concludes self-check 9.2.